These questions ask you to use Excel for calculating the confidence interval for the difference in two proportions. You can do it by hand, like I think I've shown in previous videos. If you want that formula here, I could put it on the screen here, but you could also just Google search confidence interval to population proportions formula, and then you calculate a z-score, and then you do your normal margin of error calculations for a confidence interval. We are in a technology world though, okay? So I think it's important to I don't know. I guess it is kind of important to know how to do this in Excel if you know for sure you're going to be using Excel in the workplace. But so few people use the statistics functions in Excel, and it's just more complicated. It's not as straightforward. I recommend just using an online calculator for this one. So if you type in Google confidence interval difference proportion calculator, because we're trying to calculate the confidence interval for the difference in proportions, the first one that comes up is a website, statology.org. That's a great one to do it. Our first sample was a size of 700, and it had a success proportion of 75%, so it's 0.75. Oh. All right, second sample had 850, 0.82 for a sample proportion, and then we had a 95% confidence interval, so I'll leave that there. And if you click calculate, just pay attention to where they want the decimals, 3 decimal places. There it is. First decimal place is negative 0.111, and then the upper bound is 0.029. The big thing with the statistics class now is that we shouldn't be caring so much about the nitty-gritty calculations. What we should really care about is what's the concept behind how the calculations are made. And with the confidence interval, it's the same thing. It's a parameter, which in this case is the difference of the two proportions. And this is usually estimated with p hat. We're taking this and we're adding and subtracting a margin of error to it, which is calculated using a z-score. So the distribution of proportions is going to be normally distributed, and then there's a whole thing about the binomial theorem about why we can use a z-score and not t. Okay, but this is the basic idea. The calculator does all the heavy lifting for us. We're more focused on interpreting the results. So I don't want students to be hung up too long on these types of problems where it's the calculation. The bigger thing to me is, can you interpret a confidence interval? Look, 0 isn't in this confidence interval, right? It's between negative 0.111 and negative 0.029. That means this difference is different from 0. If these two were the same, then then subtracting the two numbers should make it equal 0. Since 0 isn't a possibility according to our 95% confidence interval, then we'd say there is some sort of difference. It looks like the first population proportion is statistically significantly less than the second one. We know they are, at least in our sample. But now, because our sample is so different according to our confidence interval, now we can say with the population, hey, it's probably true that students in Okay, same website for this one. We're supposed to calculate the difference. So there's 96 people surveyed in the eastern half. 42 said they would fly to visit family. So we got the proportion there. 42 out of 96. That's 0.4375. And that was a sample size of 96 for that first sample. Now there was 108 people in the second sample, and 81 said they would fly to visit family members. So that's 0.75. Now they're obviously different. This is bigger than this. Are they big enough so that we can say there's a statistically significant difference at the 99% confidence interval? Well, let's calculate it. Just like before, 0 isn't in that interval, so we can say yes, there's a statistically significant difference.